So hello everyone, welcome back to the another lecture. So in this tutorial we will see the another operator. So we will see the two operator, one is a logical operator, another is a bitwise operator. Okay, so let's get started with this. So first we will see the logical operator. So you can see the different logical operators are there, and we have seen this particular thing in our previous classes as well, but now we will explore the meaning of all these operators. So there is a one AND operator, that is find the logical AND. Second, there is a short circuit AND, that is a two AND operator, that is logical AND with short circuiting. So what is the meaning of that? Then there is a logical NOT, logical OR with short circuiting, XOR, all, any, false, find, ISO, is logical, logical true. So these are the different types of operators are available. So now what is the difference between this particular thing, single and double and single or and double or? So we will see this particular thing through the example. Okay, so I will just jump to the my MATLAB window. Here I will assign some variables and all, and then we will see what we will get. So let us say I have on my matrix, okay, 3x3 matrix whose element are, we have already seen how to define the variables and all, right? So I have one matrix here. Okay, so this is my one 3x3 matrix. Let us say I have another matrix. So I will just taking randomly any numbers as of now. So I have assigned the two matrix. Okay, so I have two matrix available with me. Okay, you can see this matrix in the workspace. Now what I wanted to do is that, let us say I have one matrix C where I will store the A and B. Okay, A and B. So what exactly the output I am going to get? So if I'll execute it, what it will doing is that basically when if the elements are non-zeros, that time it will give the output as 1. So if you can see that it will do, it is a one matrix, another matrix, and I am doing the ANDing, one single AND. Okay, it is not the short circuited ANDing. So what output I am getting is that basically 2, 3, 4. So these all are non-zero element, and these all also are non-zero element. So that is why when one non-zero element is basically ANDed with another non-zero element, then I am getting the one logical array whose output is 1. Let us say I have a matrix B whose one element is 0. Now if I will do this particular command, then the last element is 0. Why? Because the one element of the B is 0, and the ANDing of 4 with 0 is going to give me a 0. So this is how this particular thing operates. Now what I am going to do is that I will use the two ANDs. Okay, so if I will do C, A, double and B, so this is this is my short circuited AND. If I will execute this command, then you can see the error. What the error is, basically we can't do the double ANDing with the basically vectors. This particular command is only applicable if my element are scalar. So this thing you should keep in your mind, that single AND we can use in the vectors, but double AND, which is a short circuit AND, we can't use in the vectors. So I hope so from this example how this particular thing will work and all you understood. But if we have some expression and all, that time how it will work. Okay, so I will just clearing the screen. Okay, so let us say I have one variable A whose values is basically 1, whose value is suppose 20, and I have another variable B whose value is 1. So let us say I am using X variable where I will using this one AND operator. Let us say I have my command like if B is greater than 0, okay, and single AND I am using here, and basically A by B should be greater than basically 5. So what output I am expecting here is that yes, it is logically 1. Okay, because B is greater than 0 and I am doing, and A by B is greater than 0. So single AND I am doing here. So what is the output of this? 1. And what is the output of this? 1. 1 and 1. What result I am getting? 1. Okay, because 1 and 1 logic output is 1. Now if I use the 2 AND, okay, then what is the expected output? Again answer is getting 1. So what we have conclude here is that okay, if we go with the scalar, then that time, because here is also one scalar number is coming and here is also one scalar number is coming, that time single AND or double AND we can use. But what is the difference? Let us say if this particular condition false, okay, then it will not check this second condition if we are using the short circuited AND. But if we are using the single AND, then that time if the first condition is false, then also it will check the second condition, and then 0 ending with the 1 or 0, then it will give the result either 1 or 0. But if I am using the to and, that time if the first condition is false, directly it assign value to the x is 0, it will not the check second condition, and because of this my execution time will be faster. And hence you can see in most of the code, basically where the conditional statements are used, that time double and, that is a short circuited and, is used. Okay, I hope so you understand this concept till now. Okay, so and the rest you already know. Okay, so then same way or operator will work. What is the meaning of operator? When both are 0, that time only it will give the output as 0, otherwise it will give the 1. Okay, and the remainings are there, you can learn. But what is the concept behind this, I have told you. Now the same thing it is mentioned here is that basically work with the array, this single and yes, but double and not work with the array. Short circuiting, whether this single and do no, but with double and its name is also short circuiting, and so it will do. Okay, so this is how actually this will work. And for the scalar, I have demonstrated you that this will work, but execution time of the double and, that is short circuited and, is faster one. Now next operator which we will see is the logical operator, but this is in the simulating block. Like the gates, that is AND gate, OR gate, NAND gate, NOR gate, XOR gate, XNOR gate, NOT gate. So their truth table you already know, you have learned this in basic electronics. Basically when both are 1, then output of the AND gate is 1, otherwise 0. So I have just summarized these things for you. Okay, so you can go through this. If we are working on the simulating, that time this particular logical operator we will take. Okay, based on the condition. Let us say I have one signal coming, another signal is coming, and I want the output. Okay, based on that I have to take some decision. So that time we can use in simulating these particular blocks. Okay, so this is a logical operator. Now I am not going in simulating because we are just working on the MATLAB coding and all, so I am not jumping, but I just wanted to tell you about this, so I have just shown you. Now the next is a bitwise operator. So what basically bitwise operator will do? They are work on the bitwise level. What is a bitwise level? Basically bit by bit they will calculate the things. How they will calculate, and also there is a bitwise and, bitwise or. So what it will do? So and, or, XOR, these are the same. When, what the meaning of and? When both are 1, that time only it will give the output as 1, otherwise 0. What is or? When both are 0, then only it will give the output as 0, otherwise it will give 1. Okay, the truth table you already know, but how they will work on bit level? So I will again jump to the my MATLAB window, and I will just clearing all the things. Okay, the command and all I have already discussed with you. Okay, so I'm just clearing all and CLC. Now my workspace is ready. Now let us say I have one element A. Okay, so its element A is my, let us say 52. Okay, and I have my element B, and whose value is let us say some 50. Okay, now I wanted to do the ANDing operation. So I wanted to do the bitwise ANDing operation. So let us say I am taking one element C, and I will write it down just basically bit and of A comma B. Okay, now what is the expected output? So it is showing something 48. Why the output is 41? Okay, if somebody asks you that, okay, you have taken these two variable, and if you are doing the bitwise and, then why this particular 48 output is coming? Okay, so what is the reason? Because this will not work on this 52 or 50. It will work on its basically bitwise element. So how we can represent 52 in basically 10 form? How we can represent 50 in 10 form? Then this will C will store the some value whose element are initially stored in the 10 form and calculated. Okay, A and B are stored in 10 form and then calculated using bit and then it assigned, and based on that some result we are getting, and that result is stored in the C. Okay, so this is how the operation is. So how exactly this will happen, I will just tell you. So to see the bits, we have one command, that is a bit get. Okay, so I am getting the bit for this. So basically 8, I wanted to see the bits of A. Okay, and then how much digit I wanted to see, so I will just represent it in the 8 digits. Okay, so 8 bits. So I am just write it down the thing. So this is how the command is basically. So I am just write it down the bit. So 8 bits and decreasing order and coming with the 1 bit. Okay, so this is how I write it down, and basically how it will show. So I will just write down the int 8. So this is just data type I am assigning to it. Okay, so if I will execute this command, so you can see that. So okay, so one, okay, so one small mistake is here, that I just wanted to keep two dots here. Okay, so if I will execute this, okay, some invalid expression it is showing. What is the issue? I will just find out. So I have to use the comma, not the semicolon. So I have to use here one comma. Okay, so I will just make it a comma. Now you can see that I have the bits for this. Okay, so 52, how it will represent? This is a 0, this is 1, this is 2, this is 4, 8, 16, 32, likewise. So 32 plus 16, 48 plus this 4, 52. So this is how we will represent it in the binary form. Okay, so I get the for the my A. Now I wanted for the my B, so I will just write it down here B. So you can see that bits of the A. So how the 50 can be represented? So in this way we can represent 50. Now if I have done what is a bit ANDing of the A and B. So if I will keep this as a C now, so what is the output here is that you can see that, look, so 0 0 is 0 when both bits are 1. Okay, so A bit and B bit, when both bits are 1, that time only I am getting the output as 1. Here also when both bits are 1, that time only I am getting the output as 1. And if you calculate this binary to decimal, you will find that this is a 36, this is a basically what is this 1 2 4 8 16 and 32, and 16 plus 32 you will get 48, and that is why initially when I have done this particular operation I am getting the C as a 48. Okay, so I hope so you understood how this particular thing are happening and all, and how exactly all these things are calculated. So we have seen the bit and operator here and bit get operator also. In the same way you can learn the other operator as well. So bit or is there, bit XOR is there. If we wanted to basically set some particular bit, okay, so set bit at a specific location, I wanted to alter 1 with a 0 or 0 with 1 at a particular location, then we can use the bit set operator. Similarly, if I wanted to shift, then the bit shifting operator is there. Okay, so in this way the different bitwise operator are there. You can learn this in detail if you want, and go on the mathwork side you can learn. So what basic things are required and how this particular operation and all work, that I have explained you in this video. So I hope so you understood the bitwise operator and basically logical operator in this video. So stay tuned for the next video, and happy learning. Thanks for watching.